Congratulations on completing the exercise. In this next video, we are going to introduce the notion of a function so that you can do more with your programs. Before we go on to that, however, let's first briefly review what we learnt in the first video. In that video, we learnt about variables. In particular, I explained how we can use variables to store the values of numbers. We call the value that the variable has stored the state of the variable, and we set the state of a variable b to a value of 4 by using the command b equals 4. And last but not least, we learned how we can use variables in arithmetic expressions and can thus program a computer to calculate quantities. In the previous video, I also showed the following movie in order to illustrate how we use commands like those shown at the bottom left of the slide to set the state of variables. In introducing this movie though, and the set command, I already introduced the notion of a function, as anything that changes the state of a variable is a function. The command b equals 3 is thus a function as it changes the state of the variable b to 3. To go further with functions, we have to recognize that there are two types of functions that we might call in any program. These two types of functions are the so-called intrinsic functions that are built into our program language, and the functions that you, the programmer, will yourself write. For the time being, we don't need to worry about writing our own functions. We'll come back to that in a later exercise. We are thus going to focus in this video on the intrinsic functions that we might choose to use. Python is a particularly rich language when it comes to intrinsic functions, as there are many libraries of functions that have been written by developers all over the world that we can incorporate into our programs. We can incorporate these additional functions by using an import command. Furthermore, we have already seen one of these importable functions when we were plotting our data in level 1. If you remember, to plot a graph, we use the command shown here. To use this command in a Python code, however, we have to include the library to which it belongs by adding the import matplotlib pyplot command shown here in our Python script. If we do not include this command, then our program will not work, as Python will not know how to plot the data. What you will often see in this course is the version of this command, import matplotlib.pyplot, shown here. Import matplotlib.pyplot as PLT. This command tells Python that whenever it encounters PLT, this string is to be replaced with matplotlib.pyplot. We can thus rewrite the matplotlib.pyplot command using just plt.plot, which is considerably shorter. To complete the next exercise, you are going to have to use another of these intrinsic functions. This time, however, you are going to use something from the immensely useful numpy library. You will thus need to import numpy. Notice that I have used np with this command. From this library, you are then going to use a function called randomUniform. This function generates uniform random variables, and in the case shown here, it is generating uniform random variables that lie between 0 and 1. The variable a, whose state is set by the command shown here, will thus have a value that lies somewhere on the interval shown here. Furthermore, it is equally likely to take any value in this interval. This should be sufficient information to complete the next exercise. Before we finish, however, let's first quickly summarize what we have learned in this video. We have learned that functions change the state of variables. We have learned that in Python there are many intrinsic functions that are written by other people that we can use, that when we want to use these functions, we can use the import command. And lastly, we've learnt that a function that will be particularly useful in the context of this course is numpy.random.uniform. This function generates uniform random variables that are between 0 and 1. Now see if you can use the block that generates uniform random variables to complete the next exercise.